So what we're going to start talking about now, is this idea of spread. Now we touched on this idea of spread a little bit earlier. Okay, in fact, when we're talking about means, okay, if you've got data that's quite spread out, if you've got outliers in your data, the mean is going to be skewed towards it. Okay, so what we're going to talk about now is the idea of how we can understand spread in the context of data. Now, what I've got on the screen is a real-life data set. In fact, if you wanted to go and find it yourself, you can go to this link, okay? And it's a link it's data that talks about real-life heart surgery in children, okay? So what we've got here is a graph that shows, I think it's 13 different hospitals, okay, and their survival rates after heart surgery. So basically, you've got children that go into all of these different hospitals, okay, and they undergo heart surgery, quite traumatic surgery, and this shows the survival rate after surgery. Okay, so in other words, if you just look at that bottom one, London Harley Street, it has about a 96% survival rate, which means that 96% of all of its patients survive the surgery. Does that make sense? Now have a look at that data and the way that it's presented. Which hospital would you go to? Leicester. Okay, which one? The top one? Yeah, Great Ormond Street Hospital, the top one there, okay? Why are you going to go to Great Ormond Street? It's got the highest survival rate. So because it's got the highest survival rate, it means that they must be doing something right, which means then that you probably want to go to that hospital because you've got more chance of living. Which hospital would you not go to? Harley Street. Why? Because it's got the lowest survival rate. Like literally, the length of these bars dictates survival rate. You want to go to the hospital which has the longest bar. Do you? Why not?
It's more expensive, probably.
Okay, but actually in this case, because it's NHS, we don't have to pay for it. So yeah. Good. Okay, so there might be other complications like that. But let me show you exactly the same data. So look at this data set. Okay. You said to me the top one is where you would go because it's the longest bar. And the shortest one, London Harley Street, you wouldn't go there because it's the shortest bar. Let me show you this exact same data represented in a different way. Let's have a look at the screen. Now, which hospital would you go to? Are you still going to stand by your decision? Yeah. You would, okay, fine. But my point is, if you have a look at that first graph which I showed you, I very deliberately represented the data in that way. Because if you have a look, actually, all of these hospitals have got really good survival rates. They're all above 95%, okay? They've all got really good survival rates. But the thing is, because I'm representing the data in this way, you're thinking, because that's the longest bar, and the longest bar by quite a long way, okay? It's quite a big difference. I'm going to go to the one with the longest bar, okay? But of course, if you actually put this in context and change the scale from 0 to 100%, suddenly there's not so much of a difference anymore. So are you happy it's all to do with how you represent the data? Okay? You can really mislead people just by changing the scale of your data. Yes?
In reality, let's say, wouldn't you choose, wouldn't you consider the number of operations?
Yeah, exactly. So remember, this is just a percentage. Okay, it's just a percentage. If you only performed one operation and it was a success, you could say that you had a 100% success rate. Whereas if you performed 1,000 operations and 990 of those, or 999 of those were, 990 of those were successful, then you said you have a 99% success rate. Okay, so it's all to do with the number of operations. You don't know this. I think it is embedded in the data, but yeah, that's a really good point. It's a really good point. Okay, so yeah, are you happy with how you represent the data? And it can sometimes skew things off, okay? So these two graphs are exactly the same, but one is more misleading than the other. So you just need to be aware of that. And yeah, you need to report the number of operations as well. So actually, if you go into the data set, this is the data set as it appears. So if you wanted to find it, this is what you would have, okay? You can actually see the number of operations. And yes, Mohammed, you are absolutely right, okay? You can see London Harley Street probably has quite a high success rate. Sorry, which one was the lowest one? Have I flipped it round? Haha, yeah, okay. So I flipped the number around, okay? So sorry, what was on the top of this graph is now on the bottom of this table, Okay, I think it's just the way that I produced the data in R. Okay, so you can see which London Harley Street had the lowest survival rate. Okay, but it didn't perform that many operations. Whereas Great Ormond Street had a high success rate. It performed quite a lot of operations. Okay, by the way, can you see where I got my survival rate from? Because it didn't give me the survival rate or the death rate. I had to work it out. It literally just gave me the first 3 columns. So it gave me number of operations, number of deaths, and number of survivors. How did I calculate the survival rate? How did I calculate the survival rate from the first 3 columns? Absolutely right. So number of survivors, which is the third column, divided by the number of operations. Okay, so the survival rate is just simply how many people survived out of the total number of operations that you did. Okay, and likewise for death rate, it would just be number of deaths divided by number of operations. How many people died out of the number of operations you did? Is that okay? Good. All right. So let me play on this a little bit more. Okay, what would the range be? What would the range be? So have a look at the have a look at this. What is the range in the survival rate?
95 to
1990.2.
Yep. Perfect. So the range is just the difference in the extreme values. So the highest one, take away the lowest one, which is 95.9. So what's this equal to? It's going to be equal to 3.3. So actually, if you look at that, that illustrates this graph even more, okay? It looks like quite a big difference, but actually it's only a difference of 3.3%. That's my range, okay? Range is a measure of spread. It's just simply the difference in the extreme values. Does that make sense? Okay, good. So that's just illustrating that, okay?